Interference is one of the most popular phenomena in the optics, in which superposition of two or more waves creates a regular pattern of intensity pattern in the medium. There are two types of interference. One is constructive interference and other is destructive interference. In constructive interference, the intensity is maximum, while in the destructive interference, intensity is the minimum. There are two basic mechanisms of production of the interference. One is interference produced by wavefront, division of wavefront, and other is interference produced by division of amplitude. Coherent source is necessary to produce the interference pattern. The two light sources which can produce the sustained interference are called coherent sources. Coherent sources emit the light waves having same wavelength, frequency, amplitude, and constant phase difference or zero phase difference. Now it becomes necessary to understand the superposition of light wave, which is the basic of the phenomena interference. When two or more light waves reaches at a point of the medium simultaneously, then they tries the particle to displace as per their nature. Hence, the resultant displacement is algebraic sum of individual displacements. In the superposition of light wave, the resultant amplitude is given by y equal to y1 plus y2, where y1 and y2 are the instantaneous displacement of two waves. Hence, one can conclude that the superposition is observation of the intensity at a single point, while interference is the collection of all superposition points. Resultant intensity due to superposition of two inferring waves. The waves which are responsible to create the interference are known as the interfering waves. Let us consider two interfering waves as y1 equal to a1 sin omega t and y2 equal to a2 sin omega t plus delta. Here delta is the constant phase difference. Using the principle of superposition of the waves, the resultant intensity in general point will be y equal to y1 plus y2, which produces y equal to capital R sin omega t plus phi. Here R is the resultant amplitude and phi is the phase. One can also conclude by this expression that the resultant is again a wave of same nature but with different amplitude and phase difference. The resultant amplitude can be given as r square equal to a1 square plus a2 square plus twice a1 a2 cos delta, and phase is given by tan phi equal to a2 sin delta upon a1 plus a2 cos delta. In the term of intensity, I equal to a1 square plus a2 square plus twice a1 a2 cos delta. The intensity will be maximum for cos delta equal to plus 1, and hence I equal to a1 square plus a2 square plus twice a1 a2 In terms of individual intensity, the above expression can be given as I equal to I1 plus I2 plus twice root I1 I2. Thus, at a point of constructive interference, intensity is more than sum of individual intensities. At the point of destructive interference, intensity will be of value r square equal to a1 square plus a2 square minus twice a1 a2. In terms of individual intensity, I equal to I1 plus I2 minus twice root I1 I2, which have minimum value 0. Now, a question arises that what happens in terms of conservation of energy. So, we discuss about average intensity and conservation of energy in interference. According to expression for the intensity variation graph can be shown as shown in the figure. There are alternate maxima and minima. This graph is drawn for A1 not equal to A2. For one complete cycle, average intensity is given as I average by this equation. After solving, we get I average equal to A1 square plus A2 square equal to I1 plus I2. Thus, average intensity is equal to the sum of intensities of individual waves. Thus, law of conservation of energy is followed in the interference, and one can say that energy of destructive interference point is transferred to the point of maxima, that is points of instructive interference. A young double slit experiment was the first experimental setup to show the interference in the visible light. In it, B produces two coherent sources by a single point source by making two pinholes on a screen, and then after interference. Up now, it becomes necessary to discuss the amplitude of interference. Most quick inherence of interference is evidence of wave nature of light. As all of us are familiar that the wave have both the nature, the interference produces evidence for the wave nature of light. Secondly, interference is able to explain some of the observed facts like colors of soap bubble, brilliant color observed due to oil film exposed to sunlight, intensity variation in double slit experiment, interference of sound wave is taken care for acoustically well designed auditorium. Destructive interference property is used while designing a muffler to reduce the noise due to car's exhaust system. Moreover, interference is basic for the large number of equipments used in the optics known as the interferometer. The interferometers have versatile applications in the optics. Now we shall discuss about the fundamental condition of sustained interference. To obtain well-defined observable interference fringes, following condition must be satisfied. First, two interfering sources must be coherent. Second, sources must emit the light of monochromatic wave. Third, Interfering wave must have equal amplitude, otherwise the minimum intensity will not be zero and there is a general illumination. Fourth, the two waves must propagate along the same line. Fifth, the separation between the sources must be as well as possible. Last, the two sources must be narrow. Thanks.